We're live.
We are live. And now we are live.
We're live.
All right. Welcome everybody to House Energy and Digital Infrastructure. It's Thursday, March 19th, and we are continuing to explore S202, an act relating to portable energy solar devices. So we'll go around the room and introduce ourselves, and then we'll turn it over to you to introduce yourself for the record. My name is Rep. Kathleen James, and I'm from the Bennington 4 district.
And I do provide as nothing an opportune time. I'm Scott Campbell from St. Johnsbury.
Richard Bailey, Lamoille 2.
Michael Southworth, Caledonia 2.
Christopher Howland, Rutland 4.
Garrett Torrey, Washington 2.
Graham Klepner, Chittenden 13, Burlington.
Laura Sibilia, Minnow 2.
Great. And joining us in the room,
Gabrielle Molina, Valparaiso Martin.
super. And for the record, we have invited the International Brotherhood of Electrical Workers, Local 300, to join us today. So over to you.
Thank you very much. It's not always best to sound like an attorney. It's always best to be yourself.
Correct.
Speaking as an attorney.
Yeah.
So thank you for inviting me. Again, my name's with the IBUW, the International Brotherhood of Electrical Workers, Jeffrey Wilmette. I've been the business manager of the IBEW since 2008. We represent approximately just over 1,000 union members, of which 700 are either work for the utility, the electrical utilities, or are inside wiremen. So we represent the utility workers and employees or members of the inside wireman trade. So we represent about 200 licensed electricians and apprentices in and around Vermont. So that's partly who we represent, other than municipalities, highway departments, police departments, Ben and Jerry's, so on and so forth. But I was invited here today to talk about S202. So this is a brief summary of some of my talking points regarding what you either already know or don't know, but a couple of my goals today are to give you my perspective based on who I work with. So again, we work with the utilities, represent the utility workers and the inside wiremen in and around Vermont. I was first approached on this matter by the utilities saying, hey, have you seen this bill? And I said, no, I have not. Would you testify on behalf of this bill? I'm like, yeah, it's always the utilities coming in, trying to accommodate their needs. And then they typically ask me, or I get involved when it comes to the safety aspect, but I'm not just involved with the safety aspect. I've been working in this trade for 28 years. I am a licensed master electrician in Vermont. So I have gone through the apprenticeship amongst other pathways. So I come from a wealth of knowledge, I think. I work with the utilities for the past 20 years, all of them, except for a couple. But we used to represent Vermont Yankee. So I've seen the transition from what was going on 28 years ago when I started to where it is today. And just as an example, as a licensed electrician, this is what you're supposed to know. And this gets bigger every year. And the addition of this item is not really covered in here. So part of what my goal is to kind of visually show you the requirements of a licensed electrician and what utility workers are required to know to manage those safely. And I see you have the UL Solutions white paper, which is what I utilize to create some of my talking points. So we dive into this. This is Bill 202. It talks about 50 solar devices, which is a plug and play photovoltaic device that has been created to give residents the ability to possibly offset the cost of their electrical bill and possibly make them feel like they're contributing to the health and welfare of our land. The concerns that arise with devices like this are numerous, because even though it's supposed to work properly, it doesn't always work properly, even if it's UL approved. The highest bar set in our industry is UL standards. If it doesn't have a UL stamp on it, an electrician or any tradesperson or any utility will look at it and say, I'm not touching this device. You know, if it's got a UL approved stamp on it and I don't like the device, it's still UL approved and I'm going to install it. I'm not fond of these devices because they're counterintuitive to how my brain was wired with regards to the power goes off and people used to plug in their generators and backfeed into their houses and backfeed onto the grid. And that's kind of what this does. So I'm still wired, if you will, to say this doesn't sound right, but it can be right if it's complies with UL listings. And I give kind of examples of the concerns that we have. You know, I did talk to Dennis Blair, who's the electrical inspector for the state of Vermont. I did talk to most of the utilities with regards to their concerns. So there are ways to make these devices safe as long as they're approved by UL listings. So I have two requests. One, that we meet the needs of the utility companies that provide us with the safe, reliable electricity that we get and need every day. And I know they're coming here in droves to present their cases. I've seen their modifications to the bill. As long as they're comfortable with reducing their liability meaning they're not going to get, the electrical workers are safe. The products are UL listed, meaning I plug it in, it's not going to backfeed onto the grid, it's not going to backfeed into the house. The employees will be safeguarded, hopefully. And the cost that the utility would possibly have to absorb through net metering. I know there's an article in here that secures their net metering process so that they're not being charged for that.
Right.
That's a significant item for them. Their liability with regards to the functionability of the equipment. Again, if it's UL listed, you can't argue with it. The other item has to do with, there are other items that they've talked about that aren't in there that I know they're going to present to you folks for your consideration. So as long as those items are met, I think they're okay with it. They just don't want to be liable for things that they have no control over if it's a resident owned device. And the concept of a resident owned device, you know, you have your overcurrent and fire hazards that are part of these mechanisms. Your whole primary concerns relate to overcurrent protection of the household circuit. So typically your power comes into your electrical panel and goes out to your appliances. Now you have an appliance sending electricity back to your panel board. That's not what these items were created for. That's where I'm wired the way I am in accordance with this. And again, if appliances or these devices are approved by UL solutions, which I don't believe any are at this current. They may have elements that could make them eligible for UL listing, but there are none to my knowledge. So again, And even the way they're currently manufactured doesn't meet the standards set on this book. Like the plug and play port adapters, how they plug into your house are not necessarily safe. The wiring, my biggest concern when I hear about this is new construction can be easily modified to accommodate this in the white paper. We have a lot of old housing infrastructure here. How do we accommodate those facilities with these new applications? It's kind of like, hey, here's the new device. How do we make this square peg fit into this round hole with the old stuff that we have out there? Again, this only gets bigger, and we do a pretty good job with UL listings to try to accommodate all these new products that come out. But we can't capture it all, and we can't do it all, and we can't. And the first thing, us guys tend to get busted on, we get a set of instructions and we throw them away and we try to make it work. So this has a set of instructions that currently don't follow these rules. And I'm on board with those to the extent that they comply with UL listings and they comply with this. And as long as the utilities are comfortable with what their requests are and that they're being met. And there's always concern with touch safety and shock. Again, that has to do with how these things are developed, and they currently don't line up with the manufacturing needs to accommodate the rules that we have set. There's only current production within the system. We have old residential housing. I mean, we live in a state where you don't need to be a licensed electrician to wire a house. That alone is frustrating to me and scary to me. And now we're asking a simple individual, who doesn't know anything about this stuff, who has an older model house, to take care of it and do it properly. And they don't understand a lick of what's going on. That frustrates me and has frustrated me forever. I don't understand it. I just live with it. But again, if it's UL listed, hey, I got no complaint. But if something breaks inside your house, that's your fault. And that's not how I want to view things. New housing units, new residential facilities, you could easily accommodate these requests by the UL solutions, easily accommodate. I go to my house and simply plug in something and make it work. I'm an electrician, I can do it. It's easy. Someone like yourself is going to take you about 6 months to get an electrician to go and do it. It's hard and it's frustrating.
I think Greg Campbell has a question.
Yeah, I have a couple questions.
Yes, sir.
I don't want to interrupt your flow, but you mentioned a few minutes ago about generators and backfeeding to the grid, and that suddenly hit me as, boy, that must be a hazard when the power is out and people fire up gas generators. How do they avoid being a danger to line workers?
I'll use an example like solar, commercial or residential solar devices that are either roof mounted or ground mounted have these safety mechanisms in place. They're already certified.
Right.
A generator can be UL listed if it's hooked up properly with a transfer switch, done correctly by an electrician. So there are safety mechanisms already involved that are inherently baked into the system. It's the one-off where a resident just wants to do what they want to do, how they want to do it, that ends up being the problem.
Yeah. So a generator.
Professionally done, it works. Unprofessionally done, it doesn't work.
Yeah. So these generators have a device in them, like these portable solar, and I guess inverters for rooftop solar that detect whether there's power coming from the grid, and if there's not, they shut off.
but they also go to a separate
Or they
module,
like they-
if you will, that goes to the panel. These
Yeah.
devices, these porch, what do they call them, patio, solar or whatever.
Portable solar, yeah.
They go directly to back to the panel.
Yeah,
So there's
yeah.
this concept of, and again, it's so detailed in that white paper. I really appreciate it. That they overload the wiring going to the panel. So there's no fail-safe system there, other than if your house is 50 years old, and you have this really antiquated wiring system, it may not be able to manage it like
Mm.
you do now. Even the older or the older model GFCIs, which are supposed to be plugged into, may not be able to manage the system like the newer GFCIs or the arc fault system, current protection devices. So it doesn't matter how safe that is. If they're
Plug into some.
plugging it in inappropriately.
Yeah. Well, that leads me to another question, which is, how you feel about these things being plugged into what is not a dedicated circuit. In other words, into a brand circuit where there's other loads.
You have greater liability if you plug it into something that's not dedicated. Because you, as an electrician, somebody will say, put an outlet over there.
Mhm.
They'll think, oh, that's just put an outlet over there. It could take me 2 days to put an outlet over there because I don't know where your house has been wired or what's on that circuit. So you could have 6 items on that circuit or no items on that circuit.
Yeah.
To have a dedicated circuit, I think it can be easily accomplished if done by a professional. And then you are absolutely sure there's nothing on it that would overload that circuit. Like your smoke sensors in new housing, it's supposed to be on a dedicated circuit.
Mhm.
Your older houses don't have that. So now they're modifying older houses to accommodate the new requirements. It's not exact. You know, the stars are not aligned there, but it works for now. Moving forward, given I think the interest in these devices, I think people want them. Kind of like the new iPhone. Hey, I want the new iPhone. I don't want the new iPhone. People want new gadgets to make them feel like they're accomplishing something. This allows them that benefit. It may give them a sense that they're reducing their energy costs, but at what cost?
So do you have a percentage preference for a dedicated circuit? Would you say you're 100% in favor of a dedicated circuit, or
If it's a dedicated circuit, I would have no argument.
Yeah.
And that would satisfy my needs. Because again, UL List Solutions is requesting that. There are other modifications to just the plug-in part.
Yeah.
The male adapter and the female adapter. They're not weather sensitive. They're not weather tight.
Mhm.
It's just a vacuum cord plug that doesn't fit into a GFI on the outside of a house appropriately. They're not weather tight. So there are other faults in that process, in that system. So if you have a generator that is created, built appropriately, there's typically a weather tight twist lock kind of concept for that device, where it's seasonal, it can handle whatever Mother Nature wants to give it. Whereas these things do not allow for that safety sensitivity. If it's a dedicated circuit, it means there's only one thing on it. It cannot get overloaded.
Right.
As long as that inverter is in there, in the device and UL approved, it should work accordingly to protect the people that are on the possible receiving it.
Okay, thanks.
Yeah, Rep. Sebelius.
So I apologize. I had to step out yesterday and I missed some of the testimony on this, but are you aware of any opposition to the dedicated circuit?
Am I aware? No. Should I?
I don't, I will also ask my committee, but if you're talking with folks.
Yes. As an electrician, a dedicated, go ahead.
Go ahead.
Actually, you mean opposition to acquiring dedicated circuit? Is that what you?
Yeah, who's likely to oppose, excuse me, who's likely to oppose that? And are you aware of, any of the stakeholders that do oppose that?
I am not aware of anybody opposed to it, in my professional opinion. The dedicated circuit makes things easier to accommodate the needs of the individual trying to get one of these devices.
Did you testify in the Senate?
I did.
No, you didn't, did you?
No.
I think Senator Watson texted us after they passed the bill out and said you should hear from IBEW, so we put you on the list.
Yeah.
I
So
think they ran out of time, or I don't know what.
again, it's similar to your, again, new fire alarm smoke detectors in houses are required to be on a dedicated circuit. So they don't get tripped by other devices so that they're constantly on. That's why they're on a dedicated circuit. Dedicated circuit is exactly what it is. It's for that device and that device only.
Yeah,
I would say I do have concerns about dedicated circuits in terms of the time and expense and hassle it adds to a consumer who wants to add solar to their balcony. As you said, it would take us 6 months to get someone in here.
So I'll say this, and I say this forever. Safety goes out the window when money comes into play.
And I would say,
And to put in a device, I put in a dedicated circuit, depending on the house, depending on the residence, depending on the structure, is worth the price
absolutely.
and time.
I couldn't
and
agree
energy.
that we do not want to kill anybody, either the electrical workers outside or inside the house, or the family who lives in the house, or the kids who are going to play with the plugs and whatever else not. And we don't want to burn down any houses. And it feels like, personally, I'd like to apply some creativity and try to keep finding a solution that does not require the homeowner to spend 6 months and get an electrician and have their house rewired, but also keeps everyone safe.
I have a comment on that, but a question. You were asking yesterday about and I think we should actually see if Ellen can come and walk us through the Virginia and Utah bills. I know they're not her bills, but I assume
Yeah.
she can translate the language for us. But Virginia had below a certain you were asking about this yesterday, below a certain size, plug and play was okay.
Virginia law
Somebody-
allows for 391 watts and below to simply plug in. And I believe that's based on Rep. Howland and I were talking about the fact that German standard is 800 watts for simple plug and play, and they're on 220. So you sort of take half of that and then discount it a little bit for what your actual voltage is at the outlet, and you arrive around 391. So that's what Virginia has done. And with a lower wattage limit like that, does that reduce? I'm sensing it doesn't eliminate your concerns, but
No, because again, I don't know what's on that circuit,
yeah,
nor do you. So it's your responsibility. It's their responsibility. It's UL Solutions' responsibility to keep people safe. You folks create the rules. They create the guidance. They create the rules to keep residents safe from them, safe from themselves, safe from others. And we are supposed to implement these rules, those guidances, and what you're asking for. So to just say, I agree with it, it's probably, you could view it as a safe bet, but I'm not comfortable with it.
Yeah.
UL Solutions has the best solution. I would wholeheartedly support that. I have folks in my position elsewhere who would probably say, no, don't even allow it. But here I am working with the utilities and you folks to understand that this is the next best thing that people want. So how do we make UL Solutions and this and you all align with what they're asking for? And
Oh, go ahead.
and that's kind of where I fall is these three parts can align and I would be overwhelmingly supportive.
I just wanted to say that, I think we're on the same page, because we're ahead of the market here, right? With this bill, like we're way ahead of the market. And so I'm interested in making sure that, any early adopters can use these safely if they want to and they can afford it. So I'm actually less interested right now. I am far more interested in safety right now than in parsing out what choice a consumer might make about with their money. You know what I mean? If somebody wants one of these for whatever reason, if they can afford it, if they're not worried about the payback time, if it's going to bring their energy bills down and they don't care that it's going to take them 10 years to pay back or whatever. So I'm not really interested in, and I don't think it's our job actually to think too hard about what somebody can afford and whether they want to buy one of these. I'm interested in making sure that as this market evolves, we've got safety considerations in place so that folks who want to do it now can. And then over time, I think we're probably looking, so we'll be ready. And then over time, I think we're probably looking at the future. I mean, 10 years from now, I'd love to see these be cheap and safe and you can go pick one up at Home Depot. And we are so not there yet. But one technical question I did have, I don't know if you're the person to ask this or not. And we've talked about liability. We've talked about having the AG come in and weigh on this bill to talk about like consumer protection. Mm-hmm. So that people understand when they're buying these, this is how it works. This is what it may or may not deliver to you in terms of benefits. I'm curious about if we're requiring it to be compliant with UL 3700. Who's that on? Like, because this must be common for a wide range of appliances and things. If they have to have that UL stamp of approval, is that on the manufacturer? They're not allowed to sell them into Vermont? Because I know you can do that. We do things like that all the time. Or is that on the consumer to know that they're not supposed to buy one that isn't? Or is it on the installer? Because that would be the ultimate not fair. But like who's responsible for that compliance?
It's the age-old question of, again, it goes back to the generator. There are safeguards with how a professional constructs something. As long as the professional constructs it appropriately and the device meets UL listings, they're safe. It should be safe. But if a resident goes and buys one of these devices,
right,
that's not UL approved, that doesn't meet the UL requirements. I mean, I don't know the answer to your question other than it's the resident's fault, not the professional that installed it.
Right.
Because they didn't. So again, it goes back to, we're here to prevent things like that from happening. But at the end of the day, we can't prevent all of it from happening.
Right.
So safety. So my request, again, when money comes into play, safety goes out the window. That's my attempt and others' attempts to say, as long as we cover our own butts,
yeah,
we are safe. If a homeowner does what they want to do with their castle, that's their problem and their fault, and that's unfortunate.
Yeah. Bram, and then
so I think the UL 3700 standard calls for a dedicated circuit and a unique receptacle and plug. Is that accurate.
Close to it.
And it doesn't address the whole affordability question, but one thing I wonder is if the cost and hassle of installing that could stay with the property owner, since it would be a permanent improvement rather than the renter.
Wouldn't you just pack it up and take it if you move?
Well, you take your panel, the wiring, the circuit, and the unique receptacle would stay, so that apartment would forever be configured for the next tenant who wants to add a solar panel. The renter pays for the panel, the thing they buy, but the landlord pays for the circuit and the receptacle that stays with the house. That might slice the apple in a way that gets us safety and affordability.
I would imagine the renter would have to approve somebody plugging in portable solar to their building, right?
The Virginia law requires renters to notify their landlords if they are plugging in, but does not require permission from landlords who own more than 4 rental units. So if you have 4 apartments in your own house, then you can forbid them. But if you own 5 or more, then you can't forbid your tenants from plugging in electric.
Sounds like an interesting problem.
Isn't it a problem?
Yeah. Rep Southworth?
So in your professional capacity, could you explain to us, if it's not installed on a dedicated circuit, what it will actually do to the wiring? And is there more of a chance for overcurrent in that situation? And if there's overcurrent from time to time, does that degrade the wiring to a point where there's an issue that shows up over time, not immediately?
Yes.
What is it actually?
Ultimately,
do to the
so
wiring?
what it does is so if you have appliances plugged into a circuit, so your wire runs through the wall, you got appliances plugged in, you have current running through that wire, it heats up the wire. Now you're adding a solar array and you're sending current back through the system. So you're adding more heat to that wire, which degrades the wire over time. The newer the wire, the better. The older the wire, the more degraded it is already. So it does overheat, and it would eventually either trip the device, trip the panel, or just burn up. We, over time, have created devices put in the panel or in the like GFCIs or arc fault receptors to monitor that amperage, that current, but they don't always work, and it may not work in this scenario. They may still not trip the circuit, still overheat, depending on where they're located in the wall, or in the stream of the current. It may not trip the circuit. So again, it will degrade the wire if it reaches a certain point. It degrades it no matter what. The longer you use it, the older the wire. I'm getting older. I'm not as spry as I used to be, but I still function. But yeah, and again, UL Solutions does a really good job with explaining how, if I have 5 amps coming this way and 5 amps coming this way, it's 5 amps more than I used to have. The wire is going to degrade faster. The devices may not work. The old houses that we currently live in may not have the appropriate devices currently there, and they may not put in new devices. And by adding a device, an appliance, like a portable solar that's not properly manufactured with the requirements that they're asking for. If you have shock hazard going from the device that's not UL listed, like with the devices, the caps, it could trip the circuit. It could hurt the electrician that may be working on the device that doesn't realize that something's coming in the house. So I don't know if I answered your question, but yeah, it degrades that system twofold at least.
So it won't necessarily trip the breaker in the panel if it's not an arc fault, correct?
It depends on if it's an arc fault on the end or in the panel.
On panel.
Some places put an arc fault breaker in the panel that covers the whole circuit. Some places put arc fault devices in a single location that doesn't protect the downstream.
Because I
So it
arc faults
does
in my
differ.
panel and, they trip every time power goes on and off. So
Right.
it's,
Some panels, some breakers will trip if you plug in a vacuum, because it senses something in it and it pops.
Mhm.
It's like, okay, something's either wrong with the breaker. You could have faulty breakers. I've seen faulty breakers before. So it doesn't mean the equipment may be bad, but it may mean the breaker's bad. So, but if you have the equipment that is appropriately sought, if you have and some wires not sized appropriately, like it's not big enough to accommodate the needs. All of your traditional houses wired at 15 amps, many houses are wired at 20 amps, which could possibly accommodate for some of that overload or added amperage current. But most houses aren't. My mother's house is not built the same as my house, which is 15 years old. So,
Could I follow up? Mike, can I follow up on Mike's question though?
Yeah.
I'm thinking about a situation where you have, I don't know, a toaster or a hot plate, something draws a lot on a circuit, and then you add one of these plug-in PV panels to the same circuit. What happens physically with the electrons that are feeding that hot plate or something or whatever that's drawing a lot of current at a moment, and then the PV panel is also feeding electrons back into the same circuit. What physically happens there? The current goes from the grid, from the panel to the load.
so you
And
could
then it's
view it
coming
as
also from the PV panel. So
Right.
how do those things interact?
kind of like what we had just talked about. You could view it as energy, like it's heat. So electricity current running to the outlet where your hot plate is plugged in will heat up.
Yeah.
Because you have current being pulled through it.
Yeah.
And then if you add another appliance, it gets even warmer because you're adding more current to it. If you add what you're asking for, you're adding more heat
But
to it.
it's going the other way.
It's going the other way.
is it-
It runs in a circle. So it handles it to the point, but it heats it up. So, but the other thing is,
Does it go? I'm sorry, but I'm just trying. I'm
It
not
runs in a
electrician, maybe
circle.
nobody in here is electrician except Rep Howland. But does the current go from the PV panel and then feed the hot plate, or does it? Yes. Or does it go somewhere else? Is there?
it comes through the circuit.
Yeah.
So it has to go to the panel and come out. It's a circular. It goes to the panel and comes out the breaker back to the hot plate. So it's not going directly to the hot plate, so to speak.
Okay, that's
But the other thing is sometimes your hot plate cools down and then it heats up. So your wires are going from cooler to hotter.
Yeah.
Same with your PV panel. If it's getting more sunshine, it's sending more heat. If it's got less sunshine, it's sending less heat. So your wiring's fluctuating with the heat that's going through it based on how much sun and based on how much your hot plate is operating
But
or whatever other device.
so what I'm taking away from this is also what you're saying is the current coming from the PV panel is going back to the panel before it goes out to any load.
I would think so, but I don't know. Depends on where it is, because eventually it goes into the panel and possibly back onto the grid.
Yeah.
Like some of these devices, to this gentleman's point, is they say if it's below 400 watts, that's typically what a house may use. Now, my house uses much more than 400 watts, but the hope is that you can scale it down so much that it doesn't go back onto the grid. And then at that point, what's the use of it anyways? But
And so does it go back? I'm picturing a wire. I'm sorry to belabor this, but you're the only one we're going to have in here who might be able to answer this. Because I'm picturing a wire that goes to a few loads and then maybe ends at an outdoor outlet. So there's one, that's the circuit.
Yeah.
So there's one wire. I don't know, let's call it 3 wires. Got
Yeah.
Hot, neutral, and ground. And it goes out to the it goes by a load and then out to the PV panel.
Mhm.
Does the current from the PV panel go back on the neutral back to the service panel? Is that how it works, or
I'm not an expert on that. I just
Okay.
know that your electrons are going in a circle. So it could be
Yeah.
feeding back to the panel and coming back on, or it
Yeah.
could be feeding your device specifically.
Rep. Howland, I sense,
okay?
I see your mind whirling.
All right, I got 3 or 4 questions. Well, we're gonna start with the current. So the current's gonna oscillate between power and the neutral.
Okay,
All right, so
I would call it alternating current.
alternating current.
Yeah.
All right, the sinusoidal current.
Yeah.
So what the question raised here is you are now adding, and this just came up with this conversation today. I hadn't thought about this before, but you're now adding additional neutral current. So the breaker in the panel is only connected to the power side. So it's only gonna measure power current. The danger here now is the same size 12-gauge wire that is your neutral is now going to have the additional amperage of your hot plate load plus the neutral current from your EV generator. But we'll take up with that with fire safety people and
Okay.
people.
Okay.
All right, so let me say one more caveat. My electrical engineering education is a course for non-electrical engineers. I'm a structural engineer who went to work for an electric utility. All right, and then got my 30 years of exposure. What I had concerns about is this, I think they call it a NEMA 15-5, National Electric Manufacturers. That's your plug. And that's the male plug that comes off this PV generator. So as you're making and breaking, you're disconnected. And there may be a capacitor back in the inverter that establishes the voltage or whatever. The manufacturer says that remains hot for they use a couple of seconds,
Right.
2 seconds. 2 seconds is, I think 120 cycles is a long time electrically. And so my thought on this process is to plug it in and then make and break with a switch, a breaker. And in your exposure, the old gym at the high school or school had breakers that were rated to be used as switches, but your breaker in your main panel is not supposed to be an everyday light switch. And so my concern is that when that's being disconnected, whether it's an adult or a child, is that plug remains hot for some period of time as a potential. Secondly, is that you talked about, it's called NEMA 4 for weather tight enclosure, but so that might be the enclosure around the outlet, but the person initially installing this, it may be on a wet carpet on the deck or a water exposure.
Correct.
And the idea that these things are portable is not really such, because as we spoke earlier, they have to be secured from blowing away in a windstorm. And so they're not something like putting out your heat outside furniture on a good day. People don't put them out on sunny days and take them in on rainy days. So those are some of my concerns. And particularly the log that remains hot, but you address this with a twist lock type of
The weather resistant,
weather.
and they're $30, $40.
But, so if I answered the amperage problem.
Victoria?
I just wonder, I don't know anything about electrical stuff, homes, but
Victoria?
I should. I have heard about, these fan panels, these smart panels. Would that make an appliance like this safer?
They're experimenting with smart panels. I mean, that's not even. I don't even know much about smart panels. I know somebody who may have a smart panel, but I think the smart panels have more to do with an app so that you can manipulate your power usage. As opposed to, says I think some utilities are trying to get around some of these requirements with smart panels, but even the inspectors will tell you, no, that's not how you should interpret the language with regards to how a smart panel is supposed to be utilized. They allow you to manage your output of your appliances from afar. Like, hey, I want to turn up the heat. Hey, I want to turn off my whatever. That's currently what they're doing. They're not manipulating or safeguarding anything downstream that I know of.
Rep. Sebelia?
Yeah, just
So
a quick question here, back to the dedicated circuit. I have no concept of what installing something like that might cost. Yeah.
I would, again, depending, if I use my house as an example, a couple $100.
I have a question, and then I don't know what your schedule is today, but UL is coming on with us at 10. We'd love to have you stay if you want to, but you.
Yeah, I saw they're on the list.
Yeah, you're invited. You're included. I want to get I mentioned earlier how important I think safety is, and I just want to reiterate that. And I also want to get some perspective on what level of risk and danger we're like actually talking about here. I mean, I feel like I'm not belittling this at all, but I feel like I've got a toaster I should throw away. Like what are these, what are we actually talking about here? Like, what are the odds that this is going to backfeed and shock somebody if we're requiring it to meet UL 3700 safety standards? How is this any different or more dangerous than generators that anybody can go out and buy at Home Depot or anything else? I want to make sure we're also keeping the conversation in accurate perspective.
I'll go back to, again, in my trade, something that's UL approved. People are very comfortable with installing the device. If it's not UL approved, I'm gonna have Michael install it rather than me, because I don't approve of it. And therefore it's not my liability.
Right. But that would be a violation of state law.
That's not my problem, that's his.
You ever seen my wiring skills?
Well, but do you know what I mean?
That's I'm trying to, that's the comfort level of somebody in my position as a tradesperson as well, with the level of dedication and oversight that UL puts on their products, as opposed to something that's not UL approved, where it's really up to the resident or the purchaser
Right.
to accept all liability.
And I think that's what I'm getting at. As long as we create a state law that we feel comfortable would make these safe to use, then there are infinite rabbit holes we could, I've on any bill, really, we could fall into about what if somebody chooses not to follow the law, and
That's something we
That's on
struggle
them.
with all the time.
yeah, I'm sure.
You know, again, if UL, this accommodates UL solutions. We try to keep these in alignment.
Yeah,
So whatever I'm being taught or whatever your future electricians or even plumbers are being taught falls in line with UL Solutions.
right.
Because we try to keep those in alignment because that's our comfort level.
Okay. Brett Kleppner.
For what it's worth, the AI bot did a quick search and
I love AI.
according to it, there are no reported injuries or fires from portable PV in Germany. Again, I cited the source first, but.
Yeah.
To your question of like, what's the level of risk?
Yeah.
It's one tiny data point.
Yeah. Brett
So,
Kleppner.
so I would just counter that with their electrical system is totally different than ours. Their wiring is totally different than ours, so I don't think we can compare that to what we're trying to do here. I just want to be cautious about that.
Yeah, very well taken.
Yeah, and it even makes, to your point, it spells that out in the UL Solutions. It says European standards are different than
Are
ours.
different.
If you look at the pictures of the breakers in there, they're European breakers. They're not American standard breakers. Everything in there has to do with what they do, how they do it. And sometimes they're even better than we are. Hate to say it, but they do things a little bit different. Even our code is a couple years behind. So we're constantly catching up with these new pieces of equipment that everybody wants. And we don't even have it written in here to accommodate it yet.
Mhm.
So again, that's a pretty high standard for people in this industry to follow, and they're comfortable with that standard.
Well, we have, let's see, we have UL next. We're hearing from GMP tomorrow. I don't know if she can do this, but I've already written to our attorney to see if she can help us translate the Utah and Virginia bills in particular. And then I can't remember who else we're hearing from. Oh, I missed PUC yesterday, fire safety.
Can I make one more comment? Regarding the infrastructure, the electrical grid. Every time somebody plugs in a device to reduce the cost of their electricity, it reduces, forgive me, but it reduces the income of the utility. But all these wires and transformers and substations and folks who manage these systems that we need and are constantly being upgraded because of all these new systems that are coming on board, that still has to be paid for. So every bit of energy that is now at no cost or low cost that the utilities are able to pull in is revenue sources that they lose. And I'm not advocating that they need more money. I'm just saying our electrical grid infrastructure needs to be maintained to manage all of these things. And the money that they don't get from a plug-in solar gets pushed back out to the customers anyways. Somebody's absorbing what you're saving. Somebody's absorbing what you're saving because they're not getting the revenue. And what everybody wants is low-cost energy.
Well,
Just
reduce
general.
load, right? I mean, they're also reducing the load. So when we
Right, but this,
reduce
agreed.
load by making, by reducing use and making things more efficient, we all save money as well. So I'm not quite following you on that one.
It's
However,
it's 50,
yeah,
right? We avoid having to upgrade the transmission system because we've got more local load. So we save costs there, but the utility loses and it gets.
You don't
distributed.
avoid upgrading anything. I understand what you're saying, but I would disagree. So my point is everybody wants low cost energy. How do we create low cost energy for everybody as opposed to just allowing this to go into the market without being unchecked?
okay.
Carbon neutral, safe, reliable energy.
Thank you. All right, we are, oh yeah, Laura Bailey.
So before any of these even come on, you as the worker, you're looking, and I know you're not installing, but you want to make sure that the panel has a UL sticker on it. And the plug, just whatever it takes to plug it into the wall, and the inverter part have a UL.
The panels are usually UL listed, Square D or Murray or whatever. You can buy those at Home Depot or whatever. I mean, that's.
No, but I'm talking about the panel, it's the new ones that are hanging on the balcony.
Oh,
None of
Oh, the
big
solar
panel.
panel.
those have never, none of these have gone through a UL testing that we know of.
I mean, UL just came out with the white paper, so to my knowledge, none of them have been approved.
And here we are. You will. That was a perfect segue.
There you go.
I don't think that we should take a break. Is everybody okay with just moving on? That's Celia.
Yes.
Fill this with hot water for me as long as you're,
Sharon.
there's here. Just hot water to the top. Thanks. All right, great. Thank you so much for being here and feel free to stay.
I may. They have.
Where are the waiting rooms?
Oh, great.
Call Lily and fill them in.
You've been gone for some time. Thank you.
Thank you.
Person down there.
Better. Fast forward. No, wait.
So it's still I'm concerned about the parking wire. And but it's, the real. Separate dedicated
Right.
circuit to,
Each unit.
yeah.
Yeah.
It's,
We're working on that.
you know. And the utilities are just thinking, you're just compliance, so it's kind of.
There was a reason
Our
for that.
guests have arrived.
Decent for that.
Oh, great.
A fair reason, but now we're reviewing it.
Hi. Can you guys hear us?
Yes.
Can you hear us?
Yeah, we
Great.
can.
Hi.
We're live on YouTube. Just there's your heads up. Our live stream is up and running. So thanks so much for joining us. You've not met everybody, so we'll quickly go around the room and introduce ourselves. I'm Representative Kathleen James from Manchester.
Scott Campbell from St. Johnsbury.
Richard Bailey from Memorial 2.
Michael Southworth, Caledonia too.
Christopher Howland, Rutland 4.
Dara Torrey, Washington too.
Graham Fluffner, Chittenden 13, Burlington.
And we have Representative Sebelius will be back in a minute. And Representative Morrow is joining us on Zoom as well with you today. And then we have some folks in the room. If you could introduce yourselves, please.
Gabrielle Molina, down to Franklin Martin.
Jeffrey Wilmette, International Brotherhood of Electrical Workers.
Serena Knight, BNRC. Great. All righty. So thank you for joining us. And we are interested in your testimony and also interested in your white paper. We did have a request from a committee member to do a high-level walkthrough of the white paper. So if you're not prepared to do that today, that is totally fine, and we can get you back in. But why don't we?
Okay, first let me say it's a pleasure to meet all of you. Thank you so much for the chance to provide testimony. I do have a prepared statement, and then I'd be glad to walk through the high-level concepts in the white paper and answer any questions.
Great. We just need to get you to give us your name and title for the record, both of you, please.
Great. I'm Ken Boyce, Vice President of Engineering at UL Solutions.
Super.
And my name is Megan Housewright. I am with Government Affairs, UL Solutions based in Washington, D.C.
All righty. Take it away.
Great, thank you so much. Chair, Vice Chair, and members of the committee, my name is Ken Boyce. I'm Vice President Engineering for the Industrial Testing, Inspection, and Certification Division at UL Solutions. I am an electrical engineer by training, and I've been with UL for over 40 years. Many of you may know UL Solutions by our former name, Underwriters Laboratories. Underwriters Laboratories was founded in 1894, created to test electrical products after fire concerns at the World Fair in Chicago highlighted serious safety risks. Today, UL Solutions is a leading global independent organization focused on safety, security, and sustainability. Through testing, inspection, certification, and verification, We help manufacturers, regulators, consumers, and others build trust in products that meet established safety and performance standards. Thank you for the opportunity to speak with you today about plug-in photovoltaic systems, often referred to as PIPV. UL Solutions appreciates the growing interest in PIPV technology as a way to expand access to solar energy, particularly for renters and households that are unable to install rooftop solar. We share that goal. However, our mission, working for a safer world, requires us to look carefully at how new technologies interact with existing electrical systems and the people who will use them to ensure they will do so safely. UL Solutions' work on PIPV was prompted by the passage of Utah Bill HB 340. The Utah law allows PIPV systems to be exempted from interconnection standards if the systems conform to standards in the National Electrical Code, or NEC, also known as NFPA 70, and are certified by Underwriters Laboratories. At that time, though, there was no standard to which these systems could be certified, nor specific National Electrical Code requirements that apply to PIPV. To address this gap, our engineers conducted a detailed technical review of PIPV systems and identified several unintended but serious safety hazards. These hazards span both the PIPV products themselves and also how the PIPV products can introduce hazards to the residential wiring systems. First, overcurrent risk. In a typical US home, branch circuits are protected by circuit breakers located at the main electrical panel. A plug-in PV system injects current downstream of that panel. When that injected current combines with utility supplied power, it can exceed the safe capacity of the branch circuit conductors without being detected by the circuit breaker. That creates a real risk of overheating, electrical fires, and electric shock. Second, ground fault circuit interrupter, or GFCI compatibility, is a concern. GFCIs are required in bathrooms, kitchens, outdoors, and other areas where people are more vulnerable to electric shock. These protective devices are designed for one-directional current flow. Plug-in PV systems introduce bidirectional current, which can damage or impair GFCIs, potentially affecting their response or preventing them from tripping at all during a ground fault. These products could continue to provide power, but not be able to protect the public any longer. Third, touch safety. While existing inverter standards like UL 1741 focus on grid interactive performance, they were not written to address the unique human exposure risks associated with consumer accessible plug-in PV systems. Without additional safeguards, both the AC and DC sides of a PIPV system could expose users directly to electric shock hazards. In response to these findings, UL Solutions developed UL 3700, a comprehensive set of technical requirements specifically designed to address PIPV safety concerns. UL 3700 covers system design, performance, installation instructions, mounting durability, and critically, how these systems interact with existing residential wiring. UL 3700 allows for different pathways to mitigate these hazards. Among other protections, UL 3700 requires practical methods to ensure that PIPV systems can only connect to circuits designed to handle the injected current safely. Verify compatibility with bidirectional GFCIs, maintaining the high level of shock protection Americans have come to expect. Rigorous touch safety requirements across all system components. Mechanical and environmental testing to ensure mounting hardware does not fail, and injure someone below. These protections are not arbitrary. They are an extension of the same safety principles that have driven dramatic declines in residential electrical injuries and fatality over decades. For example, expanded GFCI requirements since the 1970s have reduced consumer product electrocutions by more than 90%. New technologies must respect and not bypass these proven protections. We are often asked why plug-in solar systems used in Europe cannot simply be adopted in the United States. The simple answer is that our electrical systems, building stock, and safety requirements are fundamentally different than those in Europe. US codes are intentionally more conservative, particularly to protect children, the elderly, and other vulnerable populations. Even at lower wattages, plug-in PV systems present the same fundamental potential hazards if they circumvent established protective devices. For these reasons, UL Solutions strongly supports legislation that allows PIPV to move forward only with appropriate safety certification, including certification to UL 3700. This approach protects consumers, provides clarity to manufacturers, and enables innovation without compromising the electrical safety framework that has served this country well. Thank you for the opportunity to share our perspective. I'll look forward to questions and be glad to walk you through the white paper.
Ken, I have a couple of questions as a non-technician. It goes to a couple questions I asked earlier today. So obviously you guys are very familiar with, appliances and products bearing your sticker. And I am curious if you know, this is a really broad question, and this may be a question for somebody else, but if certain states require UL certification or, UL compliance with whatever the product is that on the manufacturer not to sell it into that state? Or is it just simply state law and it's kind of on the consumer? Like
Okay.
who's that on?
Yeah, that's an interesting question. I mean, obviously, all of you would know more about the nuances of enforcement of state laws, more so than I would. We do know that there are several levels of enforcement for electrical safety requirements. And so if there are requirements in the National Electrical Code, for example, which is what we call the model code, it's published by National Fire Protection Association, but it's not enforceable until a local jurisdiction adopts it and says this is required, with or without amendment. And so that jurisdictions vary widely across the United States. It could be a city, it could be a county, it could be a township, it could be a state. But once that jurisdiction adopts the code and says these are the requirements for electrical products, then that is enforced by electrical inspectors and other authorities having jurisdiction to conduct that enforcement. And I think there's probably a very important relationship between a state law and what would be adopted into the code. But I think manufacturers obviously would have an interest in complying with the legal requirements for the markets that they're selling products in. Consumers may not be aware of the need to comply with those, or it may vary at least. So it's maybe a little bit more uncertain how consumers may act on practical enforcement of those concepts. And then there's a role, I would think, for these local jurisdictional authorities that may help reinforce compliance with the applicable state law.
Thanks. That is helpful. And then I had another question, which was which I also posed earlier, and we're obviously as a committee very focused on making sure that these devices are safe, and can be used safely. But at the same time, I'm also trying to get make sure that we're keeping a perspective on the level of hazard. And so, I kind of asked earlier, how are these devices any more or less hazardous in the real world or statistically than like a generator I go pick up at Walmart and plug in, or, and I'm not saying this to be snarky, or like an ancient toaster I might have that catches on fire because I haven't thrown it out. Like, I want to make sure that we're keeping a sense that we really have a sense of actual risk here.
Mhm. Yeah, fair enough. I mean, I think that's a very important topic here. And obviously, again, we're just trying to keep people safe. I mean, that's really our mission,
Yeah.
and what we're constantly focused on. So we think about this exact topic all the time, and we want practical solutions that work in the real world, right? Very much to the spirit of your question. Um, I think there's a couple important issues here to think about. One is the existing electrical infrastructure that we're all very familiar with, in our households, in our workplaces, with those receptacles where we plug products in. That has worked really, really well and very safely, but it was all designed for you to plug an appliance in to that receptacle and draw power from the power structure, which basically is primarily provided by the electric utility, right? So it's all about drawing current from that circuit into the appliance to do something meaningful. You plug in your toaster, you want to toast a bagel. Now you can toast your bagel because you have a source of electrical supply. The fundamental difference with PIPV products is that now that plug is being used to inject power into that receptacle, which it was never designed for, and the electrical circuit was never designed for. It is different, and I'll talk a little bit about this. When you think about, let's say, a generator or a rooftop solar system, those are also power sources that can feed into the power infrastructure in the building, but it's done through a very well-established set of rules, done with what's called hardwiring, with conductors and conduit and other electrical products that generally are installed by qualified persons. And so it's done under very controlled circumstances. PIPV is very different, and which is part of the appeal, is that it could be easier than having to do that work. But it also is very different in the sense that now you have this uncontrolled connection from the PIPV product into the power system, which it was never designed for, and it could be done in ways that could cause these hazards. And so I think that those differences are really important and quite unique to these PIPV systems. They are not unsolvable engineering problems. As we've outlined in the white paper, we wanted people to understand these are the potential hazards that could occur. They can be mitigated. There are ways to mitigate those potential hazards. And we tried to capture that in UL 3700 as a way to say, here are product level requirements that can support safe introduction of products to the marketplace with those identifiable hazards having been practically mitigated. You asked about, kind of percentages, and we don't have that data, unfortunately. But hopefully that helps you understand the very unique aspect of PIPV products and why there are some special measures that are needed to make sure that they can be used safely.
Okay. And then one final question, and we'll turn to the white paper because I know folks want to get into that. Did you, I assume, testified in Virginia or were involved in the development of the Virginia law?
I don't
Megan,
know.
maybe you can help with that.
Yeah, I can speak to that. We have provided them with information, but we're not directly involved in, like, say, lobbying on the law or anything, just providing information.
Okay. Did you testify? I was just
No.
curious. Okay. See, we're more thorough in Vermont. We do things better in Vermont. I was just curious. I just wondered if you were interested in how that bill turned out, because they seem to have added some things that we're interested in. So I was just wondering if you had feedback on that. I think we're going to get our attorney to kind of walk us through the Virginia and Utah laws next week, if you're interested. So
Yeah, Ken, why don't I go, I can take a review of those and provide our thoughts, to you, on those, in the interim before you meet with your attorney.
That'd be great. I think, Utah, we may have, I'm not sure if we've already like left Utah in the dust. I think our bill was based on Utah, but it sounds like Virginia then, you know, got out ahead of us on some of the revisions that we're going to take a look at. So Virginia maybe especially. Okay.
Great. Okay, so did you want to walk quickly through white paper, or are there other questions we want to explore right now?
White paper.
Okay, fantastic. So it sounds like people have access to white paper and are familiar with the content in some form. Is that true?
I'd say we have access to it.
Okay,
We have it.
great.
Haven't read
Well,
it.
it is. Oh, please go ahead.
Oh, I was just saying, we haven't, at least I haven't read it all. It's pretty dense.
Yeah, but we do have it.
Okay, great. Yeah, and I think some of these topics are a little complex technically, so we realize it can be challenging to process the important aspects of this if you don't have a technical background in electrical safety. But I can talk a little bit about some of the things that I've highlighted in my testimony, but you will certainly see called out very specifically in the white paper. So the intention here was to really share the results of the research and technical analysis work that our team of technical experts undertook to really understand PIPV systems and how they may interact with the wiring systems that are embedded in the buildings where they will be used, to really understand those aspects, and then to understand the performance of the PIPV products themselves. And so we did walk through a comparison, starting off just to highlight some of those differences between plug-in photovoltaic products and other PV installations like rooftop installations, which are quite different. And understandably, some of the market appeal for PIPV products is to promote ease of use for consumers who may not have access to installing a rooftop system. And that's a worthwhile consideration, right? To allow people to make choices about how they will generate and use energy. And if you can't put in a rooftop solar system, then you don't have a choice unless you have some other mechanism like community solar that could provide access to clean energy. So it's important, though, to note that for rooftop solar, again, there's a requirement that that's installed by qualified personnel. There's a very structured set of rules about how the power that's generated by that rooftop solar system would be wired into the wiring system upstream of the breakers, and to coordinate that protection throughout the building's wiring system in a way that's very different than the PIPV products that are on the market today. And so that was one important consideration we thought it was worth addressing. I think as we see the evolution of these products, we really do want to highlight the critical role of what's called overcurrent protection. And that can be accomplished by circuit breakers or fuses. Commonly it's done by circuit breakers in most residences today, that are in a panel board, a central panel board, very close to the connection to the electric utility in a building. And those overcurrent protective devices like circuit breakers play a really important role in protecting all of the wiring and the devices that will be used inside that house on that electrical circuit. So they are able to sense when wires are being overloaded and trip, to prevent those wires from being overheated so much that they could cause a fire hazard, or that the insulation on those wires can be degraded because it's overheating, and now you can have a subsequent electric shock hazard. So those overcurrent protective devices play a really critical role. Again, they've been very, very effective. The challenge, and we spend some time in the white paper trying to illustrate this, the challenge with PIPV products is they are plugged into that electrical system and generate power downstream of the circuit breakers. So the circuit breakers are essentially blind to the power, that the current that's being injected by those PIPV systems into the wiring system. They can't protect from overloads associated with that current because they can't see it. They're upstream, electrically upstream of the PIPV product. And so this does run a risk. It certainly is possible that you don't have a circuit loaded up to its rating, say 15 amps. You may have a lower electrical load. And so in that case, a PIPV product on that circuit at that moment in time may not overload that circuit. But the circuits are designed so, and we plug things into different receptacles and turn them on and unplug them and plug them into a different receptacle all the time. And so the concept is that circuit has a rating. The overcurrent protection is set to protect up to that rated current, and then it will sense an overload. But the PIPV product would blind the circuit breaker to the overload condition. And so that means there's some real concerns about overheating those wires, overheating the devices like receptacles and the electrical connections that can overheat and cause significant fire and electric shock hazards. So we spend some time trying to explain what that looks like. Another key topic that I mentioned is touch safety. And touch safety is the idea, again, when you think of your toaster or any appliance, when you're plugging it into the receptacle, you're making a connection with the electrical circuit inside that receptacle. And now that's done safely. And now the toaster can take electricity from the power circuit and toast your bagel. The difference with PIP, and when you unplug that, you can touch the blades and it's disconnected from the electrical circuit. So there's no hazard in touching the blades. The difference with PIPV products is when light strikes a photovoltaic panel, it generates electricity, and that will put a voltage on those plug blades that you can touch at any time. And that would be an electrical shock hazard. You can get electrocuted by that. So there are requirements that electric utilities have to stop power export under certain conditions. Those are really developed to optimize the electric utility operation. It's not about minimizing a shock hazard to a consumer who may touch those plug blades. And so unless you have additional safety measures, there is an electrocution hazard for people touching those plug blades. We talk about, and so we're nearing the end. I'm certainly want to hear any questions that people may have. We talk about that compatibility with ground fault circuit interrupters or GFCIs. These are critical protective devices that have been required for many years in the electrical code, and they provide an additional level of protection from electrocution hazards. Again, they've only been designed for unidirectional current flow. Traditionally, we have requirements for bidirectional ground fault circuit interrupters, but if you backfeed them, if you have current flowing the opposite direction than what those GFCIs were designed for, you can also blind the GFCIs. And so they will continue to provide power through that receptacle, but now the consumer has lost the benefit of the ground fault protection, and they would be oblivious to that. There's no way you would know because those GFCIs now have been misused. And so that's another important consideration that would be highly relevant in terms of connection to legacy power systems. And then, in summary, I think we had kind of highlighted these are really important topics. They are able to be mitigated through effective safety engineering mechanisms. And we tried to outline what some of those could be. We, continue always to see innovation, and we're open to other innovative ways that would effectively mitigate these hazards that we've spelled out, and allowing those to be certified under UL 3700. But it's really important that we keep people safe if we're going to allow them to use these PIPV systems. So that, in summary, is a quick overview of the white paper, and I'm glad to answer any questions people may have.
Rep. Campbell.
Is UL 3700 sort of finalized?
It is. Yeah, so we published it in January, December, actually. We announced it in January just because of the holidays. But it is finalized. Now, we can change those requirements, again, if we see, new innovative ways to accomplish different methodologies for affecting the same levels of protection and safety. We can update them at any time, but it is finalized.
Do you have, I don't see that we have a copy of that. Do you have I don't know, and I don't know if a copy is really useful to the non-technical person, but I guess I'm wondering if you have a summary of the requirements.
Yeah, I mean, yeah. So Megan, I think we probably can provide a copy, right?
Mhm.
I mean, that certainly is something we'll take as an action item. Just very quickly, to kind of walk through the construct of UL 3700. So there, as with many of our safety requirements, there are some well-established pillars of the requirements. The first is construction, right? How do the products have to be built in order to minimize these safety features? And that includes some of the things like, access to hazardous voltage parts, how the mounting means would have to be resistant to corrosion and degradation, things like that, right? So we want to see it built a certain way that would mitigate those known hazards. We talk about flammability of plastic materials to minimize the risk of a fire hazard. Those are construction requirements. And then there's another pillar that's focused on performance. And so that's our testing regime, all the tests we would do to evaluate this. So we will disconnect the PIPV product and measure the voltage that's available on the plug blades and make sure that that's in a safe level before anyone could be electrocuted, for example. We'll do a series of normal operation tests where we're trying to see, as the product works the way it's intended to, it's working safely, are internal parts overheating, is there some concern about long-term degradation that may emerge over the lifetime of the product and degrade some of these safety features. So we have a normal testing regime, we have an abnormal testing regime, which is things like, we'll impact it and make sure that plastic enclosure doesn't crack and allow access to live parts. We have an environmental regime for products, especially that are used outdoors, where we'll think about exposure to water and ultraviolet light and making sure that those things don't degrade the performance of the product. And then obviously taking those concepts that I had walked through in the white paper and making sure we have testing data as appropriate to back up that there's not a safety concern with the product. And then the last pillar is really associated with markings and instructions. So we require certain markings to be on the product to inform the consumer about potential hazards and what they would need to do to avoid those hazards from manifesting themselves. There are obviously instructions about how to install the product, how to use it safely, what has to be done over the lifetime of the product to be safe in its use. And so that's a quick overview of the construct of UL 3700. Obviously, there are a lot of detailed technical requirements embedded in each of those sections to address the particular safety hazards. But yeah, we definitely can share a copy and we'll get that over to you.
Great, thanks. I just want to, one other question on this. Does it include, how does it treat the suggestion or requirement for a dedicated circuit?
Yeah, so that's one of the options that is available. And so just to be clear, it's a great question. A dedicated circuit means electrically nothing else is connected to that circuit, right? So if you think about your household, again, you'll have a number of receptacles in your kitchen. You may plug your toaster in one, you may plug a stand mixer in another. Those are probably all the same electrical circuit, and there are different receptacles on the electrical circuit, and that's fine because of the way that overcurrent protection and the wiring has been addressed to allow that type of usage. One of the concerns about PIPV, as I've indicated, is you may be backfeeding GFCIs, for example, with bidirectional current flow. If you have a dedicated circuit where there is nothing on that circuit but your PIPV product, you can still generate power. You'll mitigate the overcurrent protection issues if you have the right construct that UL 3700 requires. And so you've eliminated some of those potential hazards that I've outlined because nothing else is on that circuit, right? And so that's one way. There are other methodologies, but that's one way to allow the products to be installed in such a way that you won't have some of the safety concerns manifesting themselves.
Okay, thanks. I know what others have questions. So,
Rep. Southworth?
Similar to the way portable standby generators are hardwired into a panel, is it possible to mitigate concerns with the plug-in panels by having that receptacle wired in similar to that? Or does that not work?
No, that's a good question. And certainly that concept would be a valid one, right? So whether it's a generator or a rooftop solar system or a PIPV product, if it were wired in at the panel board using those existing rules about interconnected circuits that are very, very clear in the National Electrical Code, that would mitigate some of those concerns because now you're doing it in such a way that you have you've integrated the power source into the wiring system in a safe and established manner. So that certainly would work. That's very much different than the way we've seen the products on the market today being marketed, right? Where anybody can buy it and you can take the plug and plug it into any receptacle that will accept that plug blade, which is, throughout our house, right? Or apartment or condo. So that would be another way to say, yeah, let's use a more conventional interconnection of the source with the wiring system using established rules. That would also do it. So again, there are a number of ways that can be leveraged to effectively mitigate these hazards. So it's a good question that, using those more traditional approaches would certainly be valid.
And one last question. Have any approvals been issued yet for these through UL, or have any been submitted for testing for approval?
Yeah, great question. So we are actively working with manufacturers of these systems. We can't talk about which companies, obviously. I know you didn't ask that, but we can't talk about that just in terms of confidentiality. But there are active interactions and engagement with manufacturers of PIPV products. As of today, that has not resulted in any certifications to UL 3700, but we think that will change in the near future.
Thank you.
Thank you.
Rep. Howland?
Yeah, Mr. Boyce, I was involved with photovoltaic generation way back from 2000. The initial electronic inverters were UL certified, and then for a short period of time, a certification was lifted or removed. How do those get tracked? And I mean, we never knew whether the inverter that was on the system was pre-certification removal or post.
Okay, yeah, so maybe I'll start more generally. just to outline what the certification process looks like, and then we'll try to drive down more specifically. So if a company is seeking certification to be able to put the UL mark on their product, they would approach us and say, we would like to have authorization to use the UL mark. And then our engineering and laboratory teams will take samples of that product, assess it against the requirements that are applicable, in this case, UL 3700, as we're talking about today. And then once the product has been shown to comply with all of those applicable requirements through the establishment of very clear evidence, test data, verification of construction features, et cetera, then we would authorize them to begin production using the UL mark. At that point, our engineering and laboratory interaction with them, has been completed, but we do what's called a surveillance program, where we will go into the factory where the products are being manufactured and conduct periodic assessments at each factory where the product's being made to verify that the ongoing production has the same attributes from a safety standpoint as the products that we evaluated in our laboratories. And so the manufacturer is authorized under the terms of engagement to continue to produce with the UL mark as we do this surveillance program. They can choose to stop that at any time. And so that's really their decision. So I'm not familiar with the specific scenario that you discussed about inverters in the circa 2000. But it is, there is a discretionary aspect where the manufacturer may say, okay, well, I'm not going to produce this product anymore, or I won't produce it with the UL mark. Once it's established, there's obviously a pretty significant incentive to keep that going, but ultimately it falls to the manufacturer to make that decision about how they'd like to introduce their product to the market. We have been testing inverters for a very long time. We've seen a lot of changes in inverter requirements. And so sometimes, just one more little wrinkle on this, there are times where we look at what's being done from a technological innovation standpoint. And there are times where we say we're going to introduce new requirements that are more stringent. And that sometimes means that products that had been evaluated to legacy requirements have to be re-evaluated in order to continue to bear the UL mark. We call that an industry file review. So when that happens and there's a new set of requirements that are more stringent, we'll set what's called a future effective date. So that may be January 1st, 2028. And we say, if you want to continue to use the UL mark after January 1st, 2028, you have to show that you comply with these new or revised requirements before then. And there are some cases where manufacturers decide not to do that. So again, I'm not familiar with the specific scenario you were talking about in the 2000 era, but that there has been a lot of those types of technological developments on the inverter front. These are very sophisticated power electronics devices. They've actually evolved quite a bit in positive ways to help support the electric grid in very constructive ways, so that now buildings are not just loads on a grid. They can actually collaborate with the grid in really important ways. And as we've seen more and more renewable energy resources being deployed, there have been a lot of new features that have been added to inverters. So they're very important and sophisticated devices. So there's a lot of technological development on the inverter front. So hopefully that helps you understand kind of where we are on that.
Thank you.
Rip Torrey?
I have a question about the systems that are being paired with batteries so that you could use have access to power during an outage. Does the battery piece of that require a different UL certification?
Yeah, so batteries that are integrated into a let's say a residence or a commercial building, those are generally referred to as energy storage systems. So they also have very sophisticated power electronics devices that help them integrate with the grid, would make sure that the conductors aren't overheated. So that is all addressed very carefully. What we see with a lot of deployments across the United States, it's commonly referred to as solar plus storage. And so what we see in a lot of cases is you'll have rooftop solar that will be brought down, the electrical supply will be brought down to the panel board, and there's an energy storage system that's also hooked in right there. And so again, it's all coordinated with the wiring system that's in the building, using those well-established National Electrical Code interconnection rules. And so I've never seen a solar plus storage installation for PIPV. We may see that in the future, because the benefit of batteries is, they can store the energy. Solar is diurnal, right? Which means it generates electricity when the sun's up. It doesn't generate any electricity really at all when the sun's down, unless you have some artificial lighting coming to bear on it. But the benefit of energy storage systems is that you can use the batteries, store the energy, and then use it when you want to. When energy prices are more expensive, maybe in the afternoon, and there's a lot of demand on the grid, depending upon how that works in the jurisdiction. When the power is out, when it's convenient for you to use that energy that you generated with solar panels, with clean energy, and use that and not buy electricity from the grid, it's being generated in a variety of different ways. So there's a lot of reasons that energy consumers like to be empowered by the choices that are enabled by energy storage systems. And solar plus storage is a very powerful combination to accomplish that. But again, it's most common with rooftop solar combined with an energy storage system and put in a residence, using those National Electrical Code rules at the panel board. Does that help?
Yeah.
Okay, great.
Thanks.
Do we have any more questions? All right.
I appreciate you kind of working through. I'm sorry, I'm a little bit of a nerd. It does get very technical, but I appreciate you trying to work through the what does this mean for the decisions that you'll be making? And again, we want to certainly continue to support you in making the best possible decision for Vermont.
A nerd is exactly what we want in your position.
Yeah.
Agreed. That's what keeps us safe.
All right. Thank you.
All right. Thank you so much for joining us. And we appreciate your time. And I think we can probably go off live.
Thank you.
Great.
All right.
Thank
Yeah,
you
we'll
very
send
much.
along follow-up and appreciate the opportunity. Thank
Yeah,
you.
Thank you
so much. Bye now.
Bye.